At the end of the topic, you will be able to describe the chemical effects when electric current is passed through an electrolyte, explain the process of electrolysis, list down the applications of electrolysis in primary and secondary cells.
We know metals conduct electricity due to the availability of free electrons. Do liquids conduct electricity? Yes, it does. The passage of an electric current through a conducting solution causes chemical reactions. The resulting effects are called chemical effects of currents. When current is passed through conducting solution, it decomposes into its constituents. This process of decomposition of chemical compound in a solution when an electric current is passed through it is called electrolysis, and the solution is said to be electrolytes. Electrolyte is an aqueous solution of common salts or some acids such as sulfuric acid containing free ions for conduction of electrical current. The electrical terminals in the solution are called electrodes. Positive terminal is called anode and negative terminal is called cathode.
Next, we will learn the electrolysis of copper sulphate. Now take copper sulphate solution in a glass straw. Add some sulfuric acid to it. Now it becomes the electrolyte and ready to conduct electricity. Pass electric current through the electrodes. When current passes through the copper sulphate solution, the copper sulphate molecules split into copper and sulphate ions, that is, CuSO4 gives Cu++ plus SO4-. The copper ions are attracted towards the cathode and it is deposited on the cathode rod. There are two types of cells. They are primary and secondary cells. If the cell is used once completely by converting all chemical energy into electrical energy and cannot be recharged again, it is called primary cell. If the cell is used completely by converting all chemical energy into electrical energy and can be recharged again and again, it is called secondary cell. Dear students, scientists made a number of experiments to understand the chemicals and its reactions. We all know that during chemical reaction, heat energy is evolved or absorbed. It means that the chemical energy is converted into heat energy. Scientists proved that it is possible to convert chemical energy into electrical energy. This invention is proved and we all got a special device named as cell. Cells that can be used once and cannot be recharged are called primary cells. In this discussion, we are going to learn about primary cell and its applications. Voltaic cell was invented by Volta in 17th century. Let us learn how to make a simple primary cell such as Voltaic cell. A glass container is filled with dilute sulfuric acid and two metal rods such as copper and zinc rods are inserted into the container. A metal wire is connected to the metal rods with a bulb. Zinc slowly begins to dissolve in the sulfuric acid and bubbles of hydrogen are formed on the copper rod. At the same time, a current of electrons drifts through the wire from zinc to copper and the bulb glows. In this cell, the chemical energy contained in the container is converted into electrical energy. It can produce a voltage of 1.08 volt. We have learnt about Voltaic cell. Now, we are going to learn about Leclanche cell. This cell was invented by George Leclanche in 18th century. It consists of a carbon rod placed in a porous pot containing a mixture of powdered carbon and manganese dioxide. This porous pot and zinc rod are placed in ammonium chloride solution in a glass jar. The carbon rod acquires positive charge and the zinc rod acquires negative charge, which generates voltage. This Leclanche cell is also a primary cell. It can produce a voltage of 1.5 volt.
Let us now discuss the working of a secondary cell, namely lead-acid accumulator. It consists of two electrodes, anode and cathode, which are made up of lead dioxide and lead respectively. The electrolyte used in this cell is dilute sulfuric acid. Both anode and cathode undergo electrochemical reaction and forms lead sulphate. When the two electrodes are connected by a wire, the current flows from cathode to anode through the wire. We know secondary cells can be recharged by passing electricity through them after every use. So by passing current through the lead-acid accumulator, the electrochemical reaction gets reversed and the accumulator gets recharged. The EMF of a freshly charged cell is 2.2 volts.
In this topic you have learnt cells that can be used once and cannot be charged are called primary cells. Voltaic cell was invented by Volta in 17th century. Voltaic cell produces a voltage of 1.08 volts. Leclanche cell is also a primary cell that produces a voltage of 1.5 volt.